name is Rahim, student from Mitigation. So the title for my project is Duck Curve Mitigation through Artificial Intelligence for Optimal Work Dispatch and Grid Integration.
So the background project of my study is basically I would like to mitigate the duck curve. So what is a duck curve? So basically this is a curve that looks like a duck. So why it happened? How does it happen? It is happened due to the increasing number of PV. So when the number of PV increase, so the belly here getting deeper because it's basically the mismatch between the load demand and the PV generations. So when duck curve happen, it caused two problems, which is sinking duck belly at here. So it indicates the over generations, meaning there's supply from both grid and the PV. And also the second problem is strain on the grid that happened during this area because basically during this hour the grid work less because there's support from PV, but then during this hour there's no more solar PV because of there's no more solar irradiance during this hour at night time. So the grid needs to work harder and need to ramp up to meet the sudden demand. So basically, for my project, I refer to the California's net load. So as you may see, during 2015 to 2022, the belly is getting deeper. So I compare to the Malaysia's net load, which is from 2021 to 2024, the belly is as well getting deeper by years. Okay, so why does this study important is because when we could study this case earlier, which is to mitigate the duck curve, we could save costs in using larger battery. So the objective of my study is to develop a duck curve simulation model based on the solar generation and the load demand data, and then implement battery energy storage system for optimal energy dispatch and for peak load reduction, and also to analyze the impact of using the battery for the grid stability and for the best efficiency. So basically for my project, there's two main things, which is the algorithmic innovations, which I use AI, which is artificial neural network, which is for predictive dispatch and coordinated control, and then efficient dispatch, which for the battery, which is for precision dispatch for the when to charge and discharge the battery and to enhance the grid stability. So this is the methodology of my project. So first of all, I need to simulate the duck curve by using the MATLAB simulations. So to simulate it, of course, I need the dataset collections, which is from the load demand and the solar generations. So basically, I use May 2024's data. And then, so this is how it looks like. This is how the duck curve looks like for 24 hours. And then this is the net load for the whole month, which is for the 744 hours, May 2024. And then to mitigate the duck curve, I implement battery. So this is the battery usage for 744 hours. And then to optimize the usage of the battery, I use ANN training to train the ANN, and then it can efficiently learn when to charge and discharge the battery efficiently to reduce the peak. So when I implement the ANN, so as you may see here, this is the initial duck curve. The red line here is the initial duck curve, like here. So this is the initial duck curve. And then when I implement the battery, so the pink line here, so as you may see, it discharged during this hour. So the net load drops, and then it's and then it charged again during PV. So and then when the peak demand occur, it discharged. So as you may see, there's peak reduction during this hour. So here is the net load with and without BESS. So the red line is without BESS, this the initial one, and the blue line is with BESS. So as you may see, there's peak reduction here. So in average, I could reduce around 519 megawatts, so around 10% of the initial duck curve. So basically, my study is to mitigate the duck curve. So why does it important? It is to enhance the grid stability and to improve energy efficiency and dispatch of the battery efficiently of when to charge and discharge the battery. So the peak reduction could occur. So when peak reduction happen, it will cause less strain on the grid, and then it will lower the operating costs that need to be faced by the utilities and the grid operators. So basically, we provide an advanced dispatch system to ensure reliable power delivery uninterruptedly. Thank you. So this is demonstrations of my study. So basically this is for my ANN configurations and my battery configurations. So we need to, first of all, we need to train my ANN by using the dataset of May, PV generations and load demand. So after we have trained our ANN by using the input data, then we could run this, implement the battery to like mitigate the duck curve. Okay, so now the simulation is complete. So we may see our result here. So basically, there's summary of our from our simulations. For example, like the peak reduction that we could get. and the discharge and charge of the battery. And then also we could see the dark curve. For example, just now we could see from 19 of so basically we get the whole month of May. So we could see here we could get a peak reduction. Thank you.